Seems like a lot of people have joined us. Maybe we'll start this rolling. We're very excited for today. So welcome everybody. We'll give a bit of a welcome just as more people are showing up. We have been looking forward to this event for several months, and I know some of you have been looking forward to it too. We've heard a little bit on all of our different media channels. So thanks for joining us from whichever time zone you might be in right now. We've had over 1,000 RSVPs for this event from several continents. So we hear you loud and clear that this is an important subject for people around the globe. It was very exciting. So just to introduce ourselves, I am Jansara Ruth. I'm the co-founder and design director of Parsons Healthy Materials Lab. And I'll let Leila introduce herself.
Yes, hi, my name is Leila Bechtad, and I'm a senior researcher at the lab. And as Jansara said, we're extremely thrilled to host this conversation today.
So just to give you a little background, at Parsons Healthy Materials Lab, we convene, create, and support education for the design, architecture, and building industry to advocate for healthier built environments, particularly for frontline communities. For those of you who are new to us, Parsons Healthy Materials Lab is a design-led research lab with a small, fierce, dedicated team of researchers working from a variety of angles to cultivate awareness and adoption of healthier design practices so that all people may live healthier lives on a healthy planet. My partner, Allison Mears, and I founded the lab in 2015 with a grant from the JPB Foundation, which funds a partnership between the Green Science Policy Institute, Health Product Declaration Collaborative, the Healthy Building Network, and us. Our joint commitment is to build the capacity of the affordable housing sector to achieve the widespread use of healthy building materials, reduce toxic chemical exposures in the US building industry, and ultimately to advance healthier lives for the most vulnerable communities. Working on a variety of issues from a range of perspectives will make this vision possible.
So why this topic of carbon and chemicals today? It's ancient knowledge and also the conclusion of a global community that everything is connected. And that's particularly tangible in relation to climate change. At the lab, we see the crucial role of the design and construction industry in either causing, increasing, or slowing, maybe even reversing detrimental implications of climate change through carbon emissions. Over the last few months, we started diving into research on embodied carbon in products. And at Healthy Materials Lab, we look at everything through the lens of material health. And so we kept coming back to these questions. How do levels of carbon emissions relate to chemicals of concern found in building products? Where do we find the harmonized path to zero or low embodied carbon emissions and products free of chemicals of concerns? Or asked differently, how do we contribute to the harmonization of diverse aspects of sustainability, which all aim at the same: healthy humans living on a healthy planet Earth? And so as we're looking for an exchange on these questions and for further findings, we turn to our friends in the field and to experts. And that leads us to today.
Yeah. So today we have the great privilege to learn from Martha Lewis and Pelle Much-Peterson, which is why you're all here. So each is a leading thinker, deeply immersed in the diverse aspects of sustainability and a circular built environment. We're tremendously grateful for their willingness to share their current insights and their conversations with us from across the ocean in Denmark. the discourse of sustainability is inevitably global. As we all understand, these questions cannot be answered in isolation. So with that, I'm very pleased to introduce and welcome our two guest presenters. Martha Lewis is an architect and head of materials at Henning Larsen in Copenhagen. Her expertise and ongoing research in a sustainably built environment inspire us continuously. In 2019, Martha was awarded Denmark's Sustainable Person of the Year, and she continues to be our go-to expert advisor. Pelle Much-Peterson holds a PhD in circular facade design, the tectonics of circular economy. He's an assistant professor and researcher at the Royal Danish Academy and founder and creator of the construction material pyramid. This tool is a unique one. It gives carbon emissions a tangible value based on product groups, and it's gaining global attention at a speed that we understand even surprises Pelle. And we can't wait to hear directly from him about this and from both of you about your own discourse with each other. It's very exciting to have you. So for a little housekeeping, Leila.
Yeah, exactly. I was just about to say that. So for the rest of this hour, we're, as John Sarah said, delighted to have the opportunity to learn from our esteemed guests. To you, audience, dear audience, at the end of the presentation, we'll have time for questions from you. And so you will see there's a chat box and a Q&A function. And we would like to ask you to please only use the Q&A box. And we will then do our best to attend to as many as possible. And if you can, please use the chat function to tell us where you are. That would be wonderful to know.
And of course, you can also use the chat to add comments along the way. But at this point, we'll turn it over to Martha and Pelle. Thank you so much for joining us.
Well, thank you very much, John Sarah and Leila, for a lovely introduction. And thanks to the Healthy Materials Lab for sponsoring this very important topic and putting focus on it. It's really what we need to be considering today. I'm here to give a framework for our discussion and to specifically identify the difficult situation we are in today, March 4th, 2021, on planet Earth. In particular, I'll be revealing the extent and the challenges of hazardous chemicals in the construction sector. Pelle will continue the discussion with a focus on carbon, complexity, consumption, and an astonishingly effective material pyramid. Both of us are architects, and in that role, we see enormous potential for our profession to, at the very least, minimize the environmental impacts, if not outright implement solutions that amend the crises we're facing. If you're listening to this today, you probably already know that construction materials contribute to 11% of global CO2 emissions, of which cement is approximately 5 to 7%. This is a call to action. Reduce the amount of concrete in your projects. Build with other structural materials. Look at materials that have sequestered carbon in their growth phase. Choose materials that have the lowest carbon emissions. The UN has high ambitions for planetary well-being, and one of these is a drastic reduction of the production of hazardous chemicals. Unfortunately, the reality is that this trend is going in the opposite direction. Global chemical usage is expected to double within this decade. This is particularly relevant for the construction industry because this sector is the #1 end market for global chemicals. In fact, it's larger than the next 3 markets combined. Even in Denmark, there's a clear increase in the usage of hazardous chemicals in building products. From 2012 to 2016, there was a 58% increase in hazardous substances used in building products. This occurred in parallel with an increase in the amount of square footage that was built in Denmark. The Danish EPA commissioned a survey in 2016, which concluded that there were 48 hazardous substances used in Danish building products. Substances that are, for example, carcinogenic, mutagenic, reprotoxic, hormone disruptors, or acutely toxic in water environments. The survey is interesting because it identifies in which building life cycle phase the substances are problematic. It zones in on construction, on the use phase, and on the third phase, the end of life phase. And the results show that half of these 48 hazardous substances are problematic in the end of life phase, in the demolition phase, in the waste phase. If there is any authentic intention to limit consumption of virgin materials by encouraging recycling and reuse, then these hazardous chemicals need to get out of our recycling stream now. Last week, a disturbing new book came out with a sober title, Countdown: How Our Modern World is Threatening Sperm Counts, Altering Male and Female Reproductive Developments, and Imperiling the Future of the Human Race. Authored by Sean Swan and Stacy Colino, it's based on extensive research which identifies as the cause of these creepy changes to be environmental chemicals. That is a class of chemicals called endocrine disruptors, which includes bisphenols, PFA substances, and phthalates. In the building industry, these are used in flooring materials, in coating materials, and in polymer plastics, in paint to create surface tension, in adhesives and sealants, and in flame retardants. Many construction products, especially in the US where endocrine disruptors are unregulated, are contributing to a trend which the authors in the darkest scenario extrapolate to mass infertility by the year 2045. Think about that. That should just shake your bones for a moment. Given the amounts of hazardous chemicals in use in construction products, as well as the severity of the hazards, you would think that the building certification systems would prioritize hazardous chemical screening. This study from 2017 shows the amount of hazardous chemicals used in construction products in 4 Nordic countries. Of the total tons used, the orange indicates the tons that could potentially be targeted by a certification screening. In BREEAM in Norway, this screening is mandatory. In the other countries, it's a voluntary credit in the certification system. As you can see, Sweden is doing something quite different in the approach to identifying hazardous chemicals through screening, but that's another talk. So to return to carbon and the climate crisis, the building industry could be a major cog in the limiting of carbon emissions. However, it's absolutely essential that we make well-founded material decisions on the projects we are working on right now, today. The less accumulated carbon released into the atmosphere in the next 9 years means the less that has to be extracted from the atmosphere in the future. This is one of the reasons why we encourage you to prioritize the global warming potential in the A phase, in the production phases of the products. To sum up, I strongly advise a priority list for choosing building materials that emphasizes low carbon or sequestered carbon, that screens for hazardous chemicals, and to encourage you to think design for disassembly into your details, into your specifications, into your projects. Thank you. Pelle, it's all yours.
Thank you very much. And thank you very much for having us. It's fantastic to have this kind of discussion at this time. And as I can see in the participant list, it seems that quite the number of people are joining in on the conversation. And that is definitely the experience that I am having these days, that it's gone from being a quite nerdy subject to become almost mainstream. And that is, of course, really lovely. I am today a researcher at CNOC at the Royal Danish Academy and School in Copenhagen. And I've been so for a little more than a year now. And I'm part of this unit called CNOC, and it's been fantastic to dive in this area of expertise. Before that, I was an architect with Martha and Henning Larsen for many years, and that's why I think my research and this pyramid that I'm going to present today has a very like hands-on kind of approach also to research. But this environment that I'm part of now has been dealing with ecology and the ethics of industrial architecture basically for many years, and it seems that to join this team has been quite an advantage. So if you have the time, go and look us up, because they've been talking about this for quite a while. But today, next slide please. Today I'm going to introduce work I did as part of my PhD. There we go. Which is called the building material pyramid, or the construction material pyramid. And what is it? Well, basically, the idea was that it is an attempt to try and make architects and designers think in a different way about materiality. At least I could see that we had a very functionalistic, performative understanding of materials, and it seems that that we were thinking mostly about what functional aspects like fire aspects, the U value, how pretty or beautiful is the material, and stuff like this. And we needed to have a discussion about materiality that expanded quite far. So at one hand, we could see we had all this data, and the data was emerging at this time that we could actually see that our material choices had real impacts on the environment in a number of ways. So, so the pyramid is an attempt to try and make all this data tangible and sensuous in a way. And in its simplest form, because it started up being a poster. It just showed how much 1 kilogram, and that is approximately 2.2 pounds of material, how much that had already done to the atmosphere in global warming potential. So basically putting a value or placing it in relation to other materials, how much CO2 equivalence the material had caused just in its production. Not in its entire lifetime, but in its production. And here we are talking about CO2 equivalents. So there are other greenhouse gases, and in this kind of calculations, they are recalculated into CO2 equivalents, just to get that clear. But in the new version that we have done, we've moved the poster into a more dynamic tool where you can make your own kind of pyramid, and we'll return to this at the end. But trying to make it more interactive, we've done it with this fantastic architectural company called Vandkunsten in Copenhagen as well, that's helped us digitalize this. And now it's possible to put in your construction or some of your construction and get an idea of where you are going wrong. But we'll return to this. Next slide, please. But the idea is basically to take all this raw data that seems to confuse people and seem to not alter design, because we've seen many examples of extensive LCA analysis and a lot of data, and we could see the tons upon tons of CO2 released into the atmosphere done by an architecture, but we had a very difficult time figuring out how that should change our design. So we did not, and we continued to do architecture in the same way we had done the whole time. So my whole PhD was basically trying to operationalize this kind of data into something that I could see could change design. So what I did was basically to try and make this data sensuous and to put it in a food pyramid where you can basically use this analogy to figure out that, okay, there's something that's the red beef in the top. Maybe we should think twice about using it, or at least make sure that we get enough out of it if we use the red beefs. And then there's the bulk stuff in the bottom where you can maybe be less critical, and you maybe should put as the base of the construction. Next slide, please. But before we dive into what I really think the pyramid works well at, and how and why I think it's getting a lot of attention these days. I would just like to put a flag when you can see it, that basically this should be debated in the context of your own country, basically. And here I'm going to talk just a little bit about the surface differences between America and Denmark. Next slide, please. Here are two buildings done by Henning Larsen. The one on the right was one I was actually very involved with when I was in Praxis, and that's Microsoft headquarters in little north of Copenhagen. And the other one is Cincinnati Business School, done in 2017. And those are quite representative in the sense that they are built up to normal standards of each country. Next slide, please. But if you look at what normal standard could be, then you see that the Cincinnati Business School has on the one hand very little material at play, but also the whole discussion about energy performance we have taken to quite another level. The energy crisis in the 70s hit us hard, and we understood that we had to make sure that basically our vulnerability to these kinds of crises should be diminished. And we spent a lot of our energy in our buildings. So since then, we've just ramped up the criteria for energy performance in buildings. By doing so, we've ended in a situation where we use massive amounts of materials to construct our buildings. Just see the number of glasses in the window on the right. Next slide, please. So there is a massive difference. If you look at how the Danish energy use in buildings have evolved since the early 60s until today, basically, you could say we are not using much energy in new construction today. And our energy mix is getting more and more green. Oops, that was a bit fast. Getting greener and greener. So what you could basically see, and I think that's the important thing, but the thing underneath is that if we want to do something about the building industry, we have to look at materials, because if you look at CO2 from building operation, it is a curve that is flattening, and probably flattening more than this even. But the materials and the impacts from materials and tied to materials are going up and up and up. So we are making more and more complex buildings, using more and more material to decrease an already completely optimized building. And by using more insulation material, we get hardly any effect, but still we continue from this path. That's how hard I think the energy crisis hit us, that we can't seem to get out of this track. Next slide, please. So returning to the building material pyramid, how should you view it? And I think what I think it really can do is that you should not really view it as an answer to anything. But the first question and a line of question that we need to change, and when you listen to what Martha said, we need to change everything we know quite fast. The general ideas we have about consumption seem to be completely wrong. And it seems that all the ecological and ethical aspects of consumption have gone out the window at some point. So we need to find out ways to ask the right questions. And what could those right questions be? Well, here I'm going to present a couple of them that I've just seen students and people in practice beginning to have this kind of conversations when they meet the pyramid, because of course it's quite simple, but it's simple and maybe confusing enough or surprising enough that people start having really valuable discussions. And by doing so, I see design changing. So next slide. And what kind of discussion does it open up? Well, they look at materials and they say, what about time? Well, some of these materials will live for a long time, maybe even forever. And some, if you put a piece of wood out in the yard, it will be gone in 2 years. There must be something about time to be said about this. And of course there is. We should definitely think about the longevity of materials, and Martha also touched upon this. But the reaction sometimes, or quite often, is that we should just build with concrete then, because concrete can last 2,000 years or more. And that's what I by now call the Pantheon thesis, or the Pantheon idea, basically that because we have this one building that is essentially of concrete that's been there for 2,000 years, it does not mean that that materials will last that long, because what governs the lifetime of materials has, at least in my experience, very, very little to do with the material itself. It has something to do with what system it's in. It has something to do with politics. We are tearing down a lot of 60s and 70s buildings in Denmark now made from concrete because they're on a ghetto list. So it's a social political thing that determines the lifespan of those constructions. It can also be that it's cheaper to tear down and build new, economical reasons, and a lot of cultural reasons. And just maybe sometimes we don't find it pretty and we want to do something else. So material longevity or lifespan have very little to do with the material. It has much more to do with the system it's in, or even the typology that it's part of, and the region where it's built. So that kind of discussion, of course, is beautiful to see that people are beginning to have that discussion on after looking at the pyramid. Next question, of course, next slide. Is this like, you know, that it takes more than one ingredient to make a dish. And so it does with construction as well. And many materials have different functional uses in construction. So can you really compare insulation material to a steel beam, for instance? Well, I think you can. I think you can, and I think you should. But of course, you should take into account that they have different functional properties. They are also placed in different ways, and some you will use quite a lot of, and some you will use a little of. So basically, like the food pyramid, you shouldn't think it's just an answer and then eat only the one furthest down in the pyramid, because then you get other health problems and you won't get vitamins enough. And this is exactly the same thing you have here. We have to think about the full scope of construction. Next slide. Another thing that I think Martha also touched briefly upon is that it's very much about not just, and it also relates back to how we understand longevity and lifespan, because maybe we have to construct in a way where it's not the building lifespan that determines the material lifespan. And of course, then we need to design for this assembly, and that opens a can of worms in how we construct it, at least in Denmark, because today, because we have so highly insulated buildings, they are also completely airtight. And if you want to make something highly insulated and airtight, you have to use glues. And now we're going back to toxicity and chemicals. You have to weld things shut, and you have to use a lot of sealants and stuff like this. And one thing is that you get a very toxic environment. The other thing is that you can take things apart. And what we do today in Denmark is that we destroy everything when we take it apart. So I think we have to, and this is actually a really fun potential that I can see having great impacts on architects and designers when they take this on. Next slide. Because there's actually, and here maybe from this gloomy looking at the terrible state and we'll all be infertile in 2045, which could just destroy our year if it wasn't weird enough to begin with. But I think there's actually really a good thing to be said about this potential, because it brings a new kind of beauty into architecture. It has an almost ornamental quality when you start really designing for this assembly, because everything needs to get out of the hidden layers. You can't hide anything. Everything needs to be intuitive, and you need to be able to take things apart quite easily, and maybe even without instructions. So this is just one exhibition that I did where I tried to do, quick release friction-based construction, and this is wall panels insulated up to standard in the building code. It's made from wood and recycled wood and cork, and then the only steel, the only top of the pyramid product is the thing in the middle, the bracket where you can actually by hand release the whole thing. And of course that raises questions of, could you do that, and what about the kids? They will demount everything. But there are things to be learned from this kind of construction, and that could be taken onto a level where it would be even safe. Another thing is, next slide, that we've done this for quite long, and I have many examples of this, but here I've only chosen two, that this development we've had in construction are not doing the work it should in this kind of way. Because if you look at brickwork, and we have loads of brickwork in Denmark, historical buildings and new buildings, they used to be done with limestone mortar, and then the limestone mortar was weaker than the stone, and that means that's very easy to take apart and reuse. And then at more or less the same time as the energy crisis, we found out that this very, very strong material of cement could be used instead of limestone, and then we made limestone mortar. And now you can't take brickwork apart without destroying everything. Basically, it's gone from a kind of a chemical, in this sense, a good chemical, friction based kind of construction into, a cast-in adhesive kind of understanding, and that just makes it so that you can't reuse the materials. And the next one, and I think that's the one that we could really go on and on about, but I'll just do a short presentation, is where you basically end in the complexity of asking questions. Because if you're really beginning to look into these materials and how we use, basically what materials we use and how we use them, we end up in these quite really interesting discussions about synergy. Like one material has a tendency to point to the next. There's nothing, as I just said, called a brick wall. It does not exist, because you can't have a brick wall without mortar. And the list goes on, like the interdependencies are many and abundant. And I think even today, or how we construct today, we end up in situations where you have to ask, how basically do we understand human well-being in construction? Because I think we have to renegotiate or redefine how we work with human well-being in architecture. Because now, at least in the Danish context, we want 24 degrees Celsius in an indoor climate year-round. At the same time, we have these completely closed constructions because we want to keep the energy inside. So we end up with this massive array of machinery, making sure that we have that right balance all the time. At the same time, we have a tendency to use a lot of glass, and that means that even in a Danish country, and people used to think that we had polar bears walking around, every modern building overheats. So we have massive amount of cooling now. And we're quite good at it, so it's not that it's from an operational point of view, it destroys, our energy calculation, but the amount of material that it provokes or that it introduces into the building is enormous. And we end up often having to build, twice the volume because half the volume are machinery compensating for the fact that the building can't stand on its own, basically, that you cannot provide an indoor climate through passive means. So I think there's both a discussion about when should we wear a sweater inside, like should we really try to figure out new standards of human well-being in construction, but also looking at how the whole synergy, and let one simple choice in a sketch proposal of a glass building somewhere in Denmark will end up with so many materials and technological compensation in that building that you cannot bypass because your initial material choice was basically wrong, or at least that could be argued. So I think this, as I said, we could go on and on about, but I think we should continue and just tell you, give you a brief introduction to how this new digital version, how it works.
Sorry, I'm muted. I will share the pyramid. One quick second.
Thank you.
There is a question just while we're waiting for the pyramid to come up about how can we access the pyramid in English? It's from an anonymous attendee, so we don't know where they are.
It should translate into English straight off the bat if you access it from an IP address not in Denmark. So yeah. If you're not in Denmark, then you should see it in English. But there are many things to be said, and I think you should know that most of the data is mostly relevant in a North European context. That doesn't mean that you can't use it other places, or it won't be more or less the same image. I think it will, with minor differences. But at least, as always when we deal with data, we should be cognizant of the fact that this data is from a North European context.
Yeah.
But it works like this, and here Leila will press some. Basically, first you have, of course, you have to choose your impact, and you can choose your impact in the top left corner. And there could be many impacts, and there could be loads of things we could talk about. And it would be lovely to have stuff like health and chemicals in here. It would be lovely to have stuff about scarcity, and so many problems are tied to our material choices. But here is an array, and it's the good thing about this is that you get an idea that there's more than one thing going on. The good thing though about it is that you will often see that one kind of impact has a high impact in another place as well. then you can choose your unit, and this is a matter of taste. If it makes more sense to you to have it in kilograms or pounds, or in volume in cubic meters.
I'll pick
and then,
kilograms.
Yeah, I love the kilograms one, because I can see, at least in a Danish context, that it has a very intuitive. Most Danish people will have an idea about what 1 kilo of a material might be. So they can very, very fast be, okay, if it's insulation material, I might have this much. If it's a brick, I'll have this much. And if it's iron, I'll have this much. So they usually get a quite intuitive idea about that. And it makes it quite operational, that you can use it fast and without too many, clicks and stuff.
And just for translation, that 1 kilo is about 2.2 pounds.
Perfect. And then you can filter by group as well.
Oh yeah.
Which is some of the, and then the pyramid will change.
Sorry, I'll be quiet.
No, it's fine. And then the functional unit one is an interesting one. If you press that one as well, you can, for instance, take the insulation to U value 0.5, because some of the very, very low performing from a CO2 point of view insulation materials are very effective insulators.
Yeah.
So you would end up using way less of that material than if you're using something like wood fibers or something like that. You have to use a lot of material to get the same effect. So that is also one of the discussions that you, of course, need to have.
Mm-hmm.
But if you press the top global warming potential again to get the full pyramid, then basically the idea is that you can just press some materials, and here we could just randomly press some that you find interesting.
To select down into my list.
Yeah. So if you select them, they will point. So basically, you could be sitting with a construction and then saying, okay, I have this kind of construction. Let's have a look at what that means, because as I said, the pyramid can only take you so far. So what you need basically is, let's say we have these 4. Yeah.
Yeah. So I'm picking aluminum sheet, XPS insulation, aluminum frame window, and then foam glass. How about that?
Yeah. That's a weird construction, but for this, it doesn't matter. But so then you get your materials down there, and then you can put in the amount, and this can be done quite fast. And when I've seen it done with students, they will sometimes just guess, like do a quick guesstimation of, okay, how much I know approximately it weighs this much. I'm using more or less this and this. And then they'll get the idea, because then you can show the result in the pyramid on your left hand with red. Yeah, and if you press the one to show result in pyramid on your left, then you get your own pyramid where you can see, okay, these are aluminum sheets I might have to look into. Or if I use them, let's make sure that they last a long time, that they can be reused, that they can do everything for us that we needed to do. So it will highlight what kind of, and you put a context to the discussion that I just talked about. So I think that is the most, that's the idea behind it. What I would like to just add is that you can also double click one of the materials. So, and then it will open in a sheet on its own, and here you can get the source of the data, and you can get all the information that you need. If you find something weird or something, maybe you can go down. If you go down to the source, then you can press the about that. In this case, you don't have to do it now, but then you go to the EPD data that's behind it.
Great.
So I think that concluded the presentation.
Thank you so much. Thanks for walking me through.
Fabulous. Thank you so much, both of you. Excellent. And now we'll leave it to you to have your own.
This material pyramid has simply gone viral, and in this sense has already been extremely successful as a communication tool and reaching quite a wide audience. Congratulations on that. One of the strongest criticisms of the pyramid is that it simplifies a truly complex process. On the other hand, one of the greatest praises of the material pyramid is that it simplifies a truly complex process. Could you put a few words on that dichotomy, and perhaps with your target audience in mind?
Yeah. Well, you're absolutely right. And every tool like this and every model is a simplification. sometimes I'm astonished that the criticism is that this does not show everything about how the world works. And I'm like, no, it doesn't. I haven't seen that model yet. And I don't think it might, even if it existed, would be that interesting, because what I think we have to do now is that we have to start thinking in completely different ways. So we have to get started. And I think to say that we have to start thinking in every way, completely different ways, would mean that we would have to take on complexity that we would drown in straight off the bat. So we need to find ways to open this discussion. And of course, simple versions are the only way to do. And I think what's important if you do a simple model is that you need to make sure that people take ownership of the complexity, that it starts you on a journey where you wonder and you start asking questions. You're like, that can't be right. Like just the simple fact that that concrete is not that high up in the pyramid. Many people fall off the jeopardy. They're like, well, but this is like, I've heard this is the worst. And then even if I shut up and just let them ponder what they just said, they'll be like, oh, it must be something about quantities. Like maybe it's because we use so much of it. And I'm like, yeah. And then I try to shut up even more. And then they continue down this path of getting there. So I think there's definitely at one part of me would like it to end up being this very, very complex tool that can do everything and can tell us everything about the ethical, ecological considerations we should have on consumption. But that will never succeed. It's such a complex thing because how we consume is so much a part of it. And how we are technological animals, what we do to materials in the world, how we do live our lives in this world is such a difficult thing that this tool will never fully help you grasp. But I think that is a practical philosophical discussions that we need to have. We need to go in that direction. So I'm pleased to see that I think the tool, even though being very, very simple, starts people on this journey towards complexity, which I think is the best thing. Also, I might add that I've done many design tools, so I tried many approaches, and many of them were very complex, and they didn't work. So they might be interesting in their own right, but they didn't give people the ownership to the complexity. So I think that might be my thoughts about it. I think.
I, for one, will praise the simplicity. That having worked with huge Excel diagrams and EPDs and all of those numbers, I think that this is really the way to reach out to our profession in a more graphic, more simple, more communicative form. But that doesn't necessarily mean that it will be used in a simple way.
Yeah. That's true. But I would like to ask you a question as well, because as I hinted in the presentation, I think it would be lovely if the pyramid could talk about more things than that it's talking about now. And I think definitely the thing about chemicals and toxicity is high up. And it would be lovely to hear you talk a bit about more, elaborate a bit on the connection you see between CO2 emissions of materials and the chemical part, because that's something I've been wondering, and something that we have been discussing before, but I think there might be interesting connections that you maybe could elaborate on.
I think that that's a good question. The first thing to point out is that there's a very direct relationship between carbon emissions and the petrochemical industry, which has a large carbon footprint as an industry. So that in reducing the hazardous chemical contents in the products, or choosing different products that have no hazardous chemical content, reducing that in your whole building, you're also reducing the whole building's carbon emission footprint. So there's a very interesting synergy there that you should always be aware of. If you look at the pyramid, you can see that there are, if you look at kilos in the pyramid, you can see there are a handful of chemical-based products that do come up in the upper third or the upper 2/3, and like vinyl flooring and EPDM foil and some of the insulation products, which are highly processed products these have relatively high CO2 emissions, as well as having challenging chemical profiles, you could say. What I would really like to see coming into the pyramid is the associated chemicals that aren't in the pyramid today, but that you mentioned. For example, you can't have a brick or a brick wall without the mortar, and you wouldn't actually have a vinyl flooring unless you had the glue that was underneath the vinyl. So you have, for all of them, there is something. There are fire retardants in the bio-based materials. So I'm very curious to see the Gen 2 of the pyramid, to see what happens if this could be part of a calculation, or if this could just be a flag that comes up. In many cases, with materials, you have a possibility. You could go two directions. You have perhaps an insulation material that has a problematic hazardous chemical content, if it has a fire retardant, or you have the same product that doesn't have it. So it's very hard to put a conclusive chemical profile on a lot of the products. So I think it could be quite interesting to just at least inform that that option is there, or that you could put that in your specs, for example, and you can make better choices. It could support the choice-making process that I think the pyramid is so effective with. But the pyramid is all based on this Danish data. And I think we have a pretty international audience right now. And I know for certain that there are people in the UK and people in Norway who would really like to have their own pyramid. What's the potential for making this open source as a tool?
I think they're very good. I think it's something that we're discussing in the team at CNAC and with our partners in the industry as well, to try and figure out ways that we could do this, because it's a massive undertaking to make sure that we are on top of all the data globally. And I don't think it would be much better in essence if the pyramid could have, sister versions all around the globe. And of course, there's a kind of a risk that some would do something to it, or they would have special interest, that they will try and tweak the data in a special way. But I think it is definitely worthwhile making it open source to see how it would end, and get a better overview of all the data that's out there and all the data that is coming these years, because you really have to like a while ago we lacked data to do this kind of thing, and now it's possible, especially in the North European content. But it seems that things are happening many places, so that would be fantastic. I think it's definitely something we're working on.
Could be quite interesting to have that template that people build their own pyramid in a standard way, and that you define the ramifications for what they may and may not do.
Yes, absolutely.
So, Jansara, are there any questions from the audience?
There are so many questions from the audience.
Bet on it.
So it's fabulous to hear you both discuss this, and I think you covered a couple of them. But I think we could just start. I'm afraid we only have 10 minutes here, and we'll see. Maybe we have an extra 5 minutes. I don't know if you do, to see if we can answer more. But maybe we'll start with Layla and I were just chatting about which questions to start with. But maybe we'll start with just a question about the tool itself. Yep. There's a bunch of questions about hempcrete and hemp lime, actually, which we'll get to, because we know that a bunch of our audience is interested in that great material. But just in terms of their question, there was a question about transportation, which says, great talk. The pyramid is very helpful, but only compares materials without considering the origin. For example, if I select wood as my basic material, but it's harvested and fabricated too far away from my construction site, at what point does transportation start impacting the embodied carbon of that to a point that that it moves to a higher element in the period, in the pyramid? Sorry. And could you comment on that?
Well, yes, and I think Martha could probably elaborate as well. But I think what we've seen at a time, we thought that product miles, that's how we usually put it, that product miles was very, very important. And then we found out, looking at all phases of at least many calculations, that it was probably not that important, but definitely it's something you have to look into. And basically this ties in, this is one of the, the slides I took out because I couldn't talk forever, but product miles is definitely something you should look into. And it's something that the pyramid will say in these red lines. Where does the material come from? Have a discussion about that. Because let's say if you're using just, 2 steel brackets that are done in China, maybe it's not that bad, or if it's some very light. But if you're transporting the bulk material from the other side of the world, then of course it's something you should look into. Should also look into how it's transported. But I think it's definitely something you should have a consideration about, and it's something that once you start having that kind of discussion, you will end up being very locally based. I can see that at least with students, then they end up only using, Danish produced wood and stuff like that. So it's one of these good conversations that also like tie the whole construction and discussion to something that is ultimately better from an environmental point of view.
Great.
Pelle, there's also a bunch of questions in terms of the tool itself. I'll just name one as an example. One was what, if you can speak to what software is behind of this, but then also can the engine be integrated into a BIM model interface? And then it mentions Tally to kind of combine it into.
No, not really. The fast answer is no, it can't right now, I think. I will definitely take it up with the team, because we have this very good, we have this collaboration with an architectural firm called Vandkunsten that have done the digitization of the pyramid, and they are the ones, the data, like the software parts of this. And I'll definitely have a talk with them about this kind of thing. But I don't right now. It's not sort of being, a plug-in to anything basically. I don't see why it couldn't be over time, but right now that's not the idea. So also because we want to have, this kind of discussion very, very early. I would say to my students, I want you to think about this before you show me any drawings, right? So this should be a very early consideration.
Yeah, thank you.
Great. And I think in terms of life cycle, we have a question again about recycling. So is there a way to add whether a material is recycled or whether you're using recycled material, recycled aluminum, for instance, and would you get a different number from a recycled product or a different level?
That's a very interesting discussion, and also one that I think Martin also can elaborate on. But I think the interesting thing with aluminum is that it's the process of making, the process of reusing. There's quite a lot of reused aluminum in, new aluminum products. Like it's a very standardized process, and they use a lot of aluminum in the process of making new products of aluminum. The problem is not so much, the raw material scarcity of aluminium per se. It's more the energy used into producing new products of aluminium. So I think that's another really interesting discussion, and one I can see the people that work very seriously with this kind of get wrong. Then they think, okay, it's about scarcity, so I will use all these materials and all this to make sure that this one component is reused, and then they forget to calculate how much new material they spend in making sure that this new facade construction could actually carry this reused material. So they end up focusing too much, you could say, on scarcity, that they want to reuse this one product, and then forget to calculate the CO2 in the process of producing these things. And of course, that just goes to show that you need to have all these discussions simultaneously. You can't just say that I'm interested in raw material scarcity, because that is so dangerous and it's everywhere around us. And we know once things get really scarce and you can't feed your babies, then people start killing each other. It's really dangerous. It's really a dangerous thing. So raw material scarcity is definitely something we should talk about, but you can't forget CO2. Like that that's like taking like, and I sometimes try to have this kind of discussions in, you know, in hard resources and soft resources, and the soft resources is our atmosphere and stuff like that. Like if you forget, but people have a tendency to only think about hard resources when they talk about reuse. It's very good that we're reusing this because we'll run out of it, but not if you are making a big hole in the atmosphere, or like ozone depletion or whatever. Like, so you have to have these discussions simultaneously.
And just a low practical answer to that is it's really important to be on top of the data in your EPDs, so that what Leila showed you with the double click to get into the background data for the pyramid's built up so nicely. It's a lovely transparent pyramid. Understand the background data, because you'll often be able to read into the EPD, okay, this particular aluminum is actually made with 75% recycled, or actually that's not part of this EPD. It's you can find EPDs for aluminum that have recycled content and ones that don't. So it's important to know what you're working with.
I could just fast add on top of it that also I think that I find quite interesting with the pyramid is that we can see, and that's of course why I've become very unpopular in some areas, that it puts a lot of pressure on the industry to both make EPDs, have the right data, but also to improve on their data, which means that like right these days I just got a mail with some new EPDs that show a way better result on some lines of products, which of course then we have to figure out, okay, so should we show an intermediate or something? But you should look into it, and just because it has one value, you should still go and look for the data, because you might find one product that performs better, like one of like that does similar to the other, but performs much better. So you should always just stay aware of that.
Oh,
Yeah.
you go next.
Yeah. So as we mentioned earlier, there has been a couple of questions on hempcrete, hemp lime. One is, I was looking for cast hempcrete as opposed to fiber on the pyramid, but it does not appear to be there yet. And then I would like to add on, there's also some questions about, I'll say the best sequestering materials, you know, if we can look at this hand in hand.
Yeah, I think well, you touch upon the thing that is very difficult to have all materials in the pyramid, like and I think the 60 that we chose for this time around is the ones that are being used mostly in construction in a Danish context, which is quite unfair, basically, because a lot of the ecological products that are out there, and then they won't be represented as much because they're not that much used. But we thought about having, where do we start the conversation, and maybe by talking about all the materials that at least everyone in all architectural companies in Denmark will know instantly, will start the right kind of conversation. I could see many ways there could be a very interesting discussion about, subdividing into, these categories of materials. Like, what about just organic materials, organic based materials in one? Let's have a discussion about them on their own term. I don't know, there could be many ways to go about this, but it is true that we do not represent fully the material industry, and that's and I think there is a limit to how many materials you can take on before it gets confusing. You can't find anything then. So there's also like a graphical problem there. But at least it shows you where to go and look for the data as well if you follow the data. So it will help you to get to the right databases as well. So you could use it as a tool for that.
Yeah, I agree. It's a little bit like what you said earlier in your presentation. It's not an answer, it's a question. So I agree, yeah, to your point.
Yeah. Exactly.
Sarah, do you have one more question?
There's so many questions. There's 50 more questions to ask, but I'm going to ask one question, which really is related to the discussion you both had, which is that there's a toxicity category, and so this is a two-part question. One is, what resources will you use to populate that toxicity category? That's one, And then the second question goes forward in asking, can you give an example of where the chemical content is negative to human health while the embodied carbon is low or sequestering? So it appears, better on the pyramid, yet it's toxic, more toxic. And then there's a conflict between the chemical health and maybe both of you could comment on that.
Great question.
I'll grab the last part of that question first, and that is that I think there is a challenge with the bio-based materials, which are so fabulous and solid at the base of the pyramid, when they need to have fire retardants. And if there's boric acid used in the insulation material, or if there's any biocide treatment in the wood-based materials, the bio-based materials, this is where we get these challenges that are really difficult and really uncomfortable. And the question is, can you maybe detail your project so that you do it in another way to fire protect? Again, you always have to hold an eye on, does that mean that then the carbon is going up? And I think that we are going to have to learn how to live with these difficult choices. And the first part of the question again?
The first part is where will the toxicity information come from? I mean, it looks like there's a category for there. So the question is,
well, LCA could expand to having the toxic impacts in a LCA in data as well. Hazardous content summarized for earth and air and water. That's not used at the moment. I don't know, Pelle, if you know the status on that, but sometimes you run into that data, but very rarely. And I've always heard that it's just not the international convention and hasn't been accepted, and so it's just not used. I don't know what the future looks like, though, in terms of perhaps having that data and being able to use then the toxic impacts in the LCA viewpoint in the pyramid.
But I think it touches upon a really important part, because I asked Martha for help once because I wanted to make a tool for that as well, and it's just really difficult to access the right data and to understand the data, at least maybe not for Martha, but for the rest of us, because I was looking through the safety data sheets and stuff like that, and there you can find some, but then you need to interpret what you found basically, and that's just I find it quite difficult and not that operational. So I think definitely if it could find its way into the pyramid in a way that we could make it operational, so that it could be placed there or be placed on the materials as well as a filter or somehow, then that would be very, very interesting. So that's definitely something we're looking into.
Potentially it could be LCA data, but the other potential would be that then we went over to the H phrases. And in that case, you need to have material passports or material product declarations or health product declarations, so that you actually can access some of this health information and content information that we have today to a certain degree in some countries, better than others, the safety data sheets. But that's all for these liquid products. But for articles, we need another documentation that doesn't exist.
That's great. I think we now are up to 60 questions, but I think what we'll have to close. Thanks for staying a couple extra minutes. Just the last question in our queue was, what should an architect or designer do? What's the first step they could do towards making a zero carbon and healthier project? What would you say is like the first step?
I could answer some of it, and then maybe Martha as well. But I think definitely we have to look at how we do things. And at least in a Danish context, we view architecture going from the very abstract to the very literal. So we start up having ideas. We work into 1 to 1,000, 1 to 5,000. We are abstract in our understanding. We are, from the helicopter looking down at things, and then we make sketch proposals and competition based on what from there. And that is not a way of conducting architecture I think works. I'm not saying everyone does this, but at least that's a tendency in a Danish context. I think we have to reverse the process and start from the other end, from the detail, from the material choices, from all of that. Sometimes I think I had this wonderful conversation once with a PhD from the States, and he said, okay, Pelle, what you're talking about is that you are actually asking people to say, show me your palette, show me your moves, and show me your take on well-being. That's basically what you're saying. And by palette means the first thing you should do is figure out, what are you drawing with? What's the material in every line on paper? Because they are always representative of some material. Then secondly, what's your technical, low tech? What's your technical approach? How do you design your details? What's your idea about how two materials are combined? And then finally, or in the same breath, preferably, what's your take on human well-being? How are we going to ventilate this house? Can we do that by passive means? Can we just open a window? Can we do stuff? What happens to the operational energy? Do we have enough thermal mass so we can just do this? Like these kinds of discussions that talks to, the whole of architecture and how we understand humans in architecture needs to be not in the detailing and in final discussions of, of design where you can't change anything because you have already sold it to the client and he loves it, and the glass building, it was shiny and looked great in renders, but now they want to change the whole thing and you can't do that. So I think we have to flip the way that we, from a methodological point of view, how we address architecture. And the first question is, what are you building with?
Great answer.
We have to raise the bar on our knowledge level. We have to tackle some of these things that we've never confronted before. We have to go find that EPD that we've never really looked at or never really understood what it was. And we have to understand, what information am I getting out of this? And then we have to do a strong campaign to get more health product declarations and material passes established so that we have more transparency with the materials that we're working with.
Great. Thank you both for all of your incredible research and work that you're doing to push this industry forward for all of us. And it's huge what you're doing for everyone. And so we're super grateful for that and for your insights today and your candid nature and your easy to understand presentation and simplifying this information so we can make it sensuous and for providing us the kind of terrifying information as well that shows us why we need to change, why we need to really make these changes and now. It's great to have you here.
We have shared the website to the pyramid in the chat. I'm sharing it now one more time because I would really encourage all the participants to go and start playing with the pyramid. That might also answer some of the questions. And so thank you again.
Yeah.
Thank you. Thank you very much for having us. It was an absolute pleasure.
Thank you, Healthy Materials Lab.
Thank you. And if you want to follow, keep up with other events that we're hosting here and helping to just get this word out, please follow us on Instagram or LinkedIn or Facebook. I also put the link to sign up for our newsletter in the chat. So we can stay in touch and keep helping to provide these geniuses with a platform. So, and thank you all for coming today. It's great to hear all your comments and your sharing with each other about these great stories, which I can't wait to read the chat later.
Okay.
And we'll share it with the panelists as well.